This webinar or training will be recorded. If you need certificate of completion, please indicate your name and agency in the chat as indicated on the sticky, and those will be emailed to you. Excellent. So with that, today we are going to be talking about the Secretary of the Interior's guidelines for rehabilitation. I will note that this is not all of the guidance provided by the National Park Service on various aspects of doing a project, but these are the, I would say, the most, these are the topics that I get the most questions about during my reviews, as well as when I'm out on site or just talking to people about their particular projects. So know that this is not an extensive uh, training on various guidance that is provided by the Park Service, but the most important ones, or at least the ones that I encounter more often than not. So with that, I will turn off my camera. That way you can just look at the slides. All right. So first up is we're going to talk about windows. Windows in historic buildings, probably one of the biggest pitfalls and areas of concern when it comes to historic rehabilitations. Any determination about what to do with the windows in a rehabilitation project must begin with evaluating the existing windows if they are historic. Replacement windows should be considered only if the existing windows are not historic or are missing altogether. Evaluating windows for repair or replacement, deterioration should be the primary concern in evaluating historic windows, though there can be other factors to take into account. When may existing windows be replaced? Standard 6 states that historic features should be repaired rather than replaced. Even extremely deteriorated windows can be repaired, but beyond a certain point, repair may not be reasonable or practical. So for a level of deterioration, the true condition of a window may be concealed by peeling paint and missing putty, which are easily corrected. Even severely weathered surfaces and pockets of decay may be repaired with modern epoxies, but it is most reasonable to make this sort of repair if it only involves limited areas. It may be harder and more expensive and thus not practical to make a window sound and functional if the joinery has failed. Full, detailed window surveys are often not needed. While it may be useful to systemize the evaluation of the window conditions with a structured window survey, a generous quantity of good photographs that target the significant conditions will be adequate in most situations to substantiate the treatment proposed for the windows. A sample repair can provide real information about both the cost of repair and also the quality of the end product achievable through the repair. For considerations beyond deterioration, while Standard 6 does not specify what elements of a building should be repaired rather than replaced. Standard 2 acknowledges that all parts of a building are not equally critical to preserve. Standard 2 states that character defining materials and features should not be removed or altered. Windows vary in their importance, and while windows in most historic buildings make a significant contribution to their character, all windows are not equally important to the historic character of all historic buildings. The building on the left is all about windows, while on the right, the windows on the primary facade of the building are also important. The windows units themselves are cast in shadow by their deep placement in a wall that has a strong architectural presence with a bold cornice and other three-dimensional features, and therefore become kind of less important in the overall scheme of the facade. Standard 5 states that distinctive features, finishes, and construction techniques or examples of craftsmanship that characterize a property shall be preserved. This reinforces the importance of preserving those windows that are particularly distinctive. Many windows, such as standard manufactured units, are less distinctive in and of themselves. Even the most ordinary windows, however, can still be important components of the pattern and texture of a building's elevation. Where the window is located on the building can affect its importance to the building's historic character. If an elevation is secondary due to its architectural treatment, its visibility, and its function, the windows that are a part of that elevation will obviously also be secondary. Some additional factors help determine the practicality of retaining and repairing windows and may appropriately be considered in conjunction with other deterioration. This includes occupant operation, hazardous materials, code requirements, and energy performance. Storm windows and weather stripping. So, energy is most often the driving force in the desire to replace historic windows. But in most cases, substantial improvement can be made to the performance of historic windows without replacing them. Well designed and carefully installed weather stripping can reduce infiltration. Storm windows, either interior or exterior, can reduce transmission losses. Exterior storms have the added benefit of protecting the historic window itself, which more than compensates for their impact on the appearance of the window. When it comes to storm windows, we try to have the mullions and hit the meeting rail. That way, the overall pattern and proportions of the window are still evident. So, replacement windows that meet the standards. The approach to replacement windows will differ depending on whether or not historic windows remain. Some of the same considerations used in deciding the importance of retaining and repairing a window are applicable for determining what constitutes an appropriate window replacement. Again, Standard 6 Any replacement for for a historic window should meet the requirements stated in Standard 6. The new feature shall match the old in design, color, texture, and other visual qualities, and where possible, materials. Primary elevations or facades of 3 stories or less. The windows that are most important to the historic character of a building must be the most accurately matched if they are to be replaced. Obviously, this means the primary elevation, the front, as well as street facing and any other highly visible elevations. On buildings of 3 stories or less, most of the windows can be readily seen from the ground, and replacements must accurately replicate the historic windows in details and materials. Similarly, at the base of very tall buildings, both details and materials are important to the match of the replacement windows. Typically, the windows at the base of a tall building are different from the rest. Often there's an architectural feature, such as a frieze or a cornice, which sets the base apart. It is generally appropriate to use substitute materials for the windows above that line where the window types changes, but details must match to the extent that they can be seen. Regardless of the size of a building, requirements for the replacement windows on secondary elevations that have limited visibility are less stringent. Usually the same basic type of window must be used and the opening must be completely filled, even if the details have some variations. When there are significant interior spaces whose character must be preserved, the effect of the window on that character must be taken into account. In some cases, this may require materials and details that would not be needed if the replacement were evaluated from the outside alone. Note the negative impact of the white aluminum or vinyl replacement window on the interior of this formal wood paneled room. For important elevations of mid-rise buildings, replacement windows should generally match the existing historic windows. In most cases, wood windows with accurately matched details should always be considered first when replacing historic wood windows. Substitute materials can be appropriate or slight variations in details acceptable when it is clear that the visual effect of such change is inconsequential. In the building pictured here, matching aluminum sash with insulated glass and simulated divided lights replaced the historic wood sash. While most window replacement projects involve installation of an entire new window unit, sometimes only the sash must be replaced. Evaluating the match of the replacement windows should be based on comparing the drawings of the existing historic windows with drawings of the proposed replacements. This is the fastest and least expensive approach for checking the match of dimensions and profiles. It is not always easy to predict from drawings the effect of deviations in the dimension or shape of some elements in the replacement window. In the end, it is the cumulative visual effect of all details and dimensions that determines the quality of the match. While drawings help to make reasonable judgments about how well a replacement unit will match an existing window, looking at a sample of the replacement that has been installed always provides the most complete information. When tight schedules and fabrication limitations do not permit a full mock-up, a manufacturer's sample can be helpful in understanding what the new window will actually look like. Evaluating how well the replacement window will match the old window involves a number of factors, including window unit placement, window frame size and shape, glass size and divisions, sash elements, width and depth, material and finish, and glass characteristics. The new window needs to be installed in the window opening in exactly the same plane as the historic window, neither forward nor back. While different elevations may, in some cases, have different window setbacks historically, it is easy to see how window placements can affect the apparent mass of the wall. Note in this example the different appearance of the two elevations resulting from the fact that the windows on the front facade are more deeply recessed than those on the side. Even within a window unit, the relative placement of the component parts is important to ensure that the historic character of the window is not lost in a replacement. The overlay depicted on the left of a proposed aluminum replacement for a window with a transom illustrates a substantial and inappropriate change in the location of the transom sash. Yeah. Substantial changes in the dimension and profile of the elements that frame a window will change its character. Left is the historic window, and right is the replacement. The specific profile of the brick mold is usually less critical than its overall complexity and general shape, such as stepped or curved, in defining the distinctive character of a historic window. Typical sightlines reduce the importance of the size and profile of the sill on windows high above the ground level, especially when the windows are deeply set within the wall. Mullions generally take one of two forms. Either the brick molding is incorporated into the edges of the mullion, or the mullion is set back behind the level of the brick molding at the plane of the blind stop. Though a blind stop is a small element of the overall window assembly, it is a noticeable part of the frame profile, and it is an important part of the transition between wall and glass. Part of the noticeable difference between the historic window on the left and the two replacement windows is due to the blind spot. Steel windows that were installed as a building's walls were constructed on the left, have so little of their outer frame exposed that any replacement window on the right will necessitate some addition to this dimension, but it must be minimal. Using insulated glass units in replacement true divided lights below will require larger muntins than what is typical for historic muntins above in most applications. 2/2 windows are the exception. While true divided lights in new windows can be fabricated by some manufacturers to come very close to the dimension of historic muntins on the left, even small increases in size are perceptible on the right. The historic window behind the storm window on the left has a very narrow muntin at the top sash and a wider muntin at the bottom, but both have a simple trapezoidal shape. The almost matching replacement window on the right uses a single size muntin that appears to have more of a beaded shape to it. Large, thick, historic sash often had a deep putty line. Even if the muntin width can be correctly matched, the appearance will be quite different if the depth is reduced. The whole assembly can appear flat and false in comparison to the original. Simulated divided lights, or SDL, is the industry term for a three-part assembly that consists of a three-dimensional grid applied to the exterior, backed up by a spacer within the insulated unit, and another grid applied on the interior glass surface. This system allows greater flexibility in muntin size and profile and can be an effective imitation of true divided lights when carefully executed. Applied muntins must not appear obviously false. They may become deformed and bow out from the glass if they are not sufficiently rigid or well attached. An applied exterior grid without the in-between glass spacers or an interior grid does not adequately replicate authentic muntins. For a typical hung wood window, the size and proportions of the frame, the sash that holds the glass, are important to the appearance of the window. Using replacement sash that is too thin, as in the replacement windows shown at the bottom, results in a loss of shadow at the meeting rail. This makes the window seem flat and thin compared to the historic window above. The difference in the sash is the reason that these two replacement windows look different. On the second floor, the top rail of the top sash is roughly equal in dimension to the styles which is typical for most historic wood windows. The first floor windows have styles that are wider than the top rail. The typical historic configuration shown on the left is not replicated when rails and stiles of the sash are reduced to little more than a thin outline, barely visible beyond the blind stop in the window in the center. The third window shown on the right is a full replacement inserted within the frame of the historic window. The new window has very narrow sash pieces, but a substantial additional blind stop. A thin or skimpy top rail is typical of many aluminum window installations, but a better match can easily be achieved by adjusting the size of the window and altering the installation detail. The details at the top of a window remain visible even as other details are diminished in importance due to the sightlines of windows higher up on the building. Many single-hung and fixed aluminum windows are made without a true upper sash on the left. Thus, they lack the proper configuration at the meeting rail to allow for an OG extension or lug of the upper sash style. A lug is a distinctive detail found on many historic window sash on the right. Most replacement windows attempt to replicate the detail of the lug with an added piece. Since historically the lug was an integral part of the style, it is critical that any installation minimize that joint. Some historic windows had features or dimensions that did not perform well from the outset. The delicate meeting rail is insufficient for this large window and required the addition of a metal tie rod to help support the window. If this window were to be replaced, it would not be reasonable to require the new window to match a historic feature that was obviously inadequate. The dimension of the meeting rail is important to the character of the window. When modest-sized historic windows on the left were replaced with units designed for much larger openings, the meeting rail is likely to be too large as shown in the replacement window on the right. There are a number of seemingly minor points that individually may not be significant in evaluating the match of a replacement window, but when taken together with other changes, can result in a poorly matched window. One such item is the upper rail of the bottom sash. On historic windows, it was always flush with the bottom of the upper sash. But in some replacement windows, the upper rail of the bottom sash is too deep, and as a result, it is visible well below the upper sash. While using a wood window to replace a historic wood window will usually result in a better match in most of the details, some modern wood windows have features that are inconsistent with historic windows. This modern window uses a flat glazing clip instead of a three-dimensional stop that approximates the putty line of a historic window. It would not be possible to have a three-dimensional Munson grid with this type of window. Part of the distinctive character of industrial steel windows is the pattern created by frames of the operating sash against the background of the muntins. The operating portion of historic steel sash is distinguished not only by its frame being wider than the muntins, but also by the muntin's slight projection, which can be seen in the restored historic window on the lower left. The replacement window shown in the upper left approximated much of the historic pattern, but is completely flat without the profile of the historic sash. Right, an inexpensive addition to the muntins on the operating portion of the windows provides a three-dimensional quality that makes them a better match. New windows manufactured of substitute materials not only have different finishes, but also have different profiles and dimensions from wood windows. Wood windows are assembled with orthogonal joints and have painted surfaces. Some vinyl or enameled aluminum windows, such as these shown here, have mitered joints and overlapping surfaces. These details can give the window a different appearance and thus may not be appropriate replacements for wood windows. Until recently, the light color of the vinyl tracks that are a standard part of modern manufactured windows stood out in harsh contrast when the windows were painted a dark color. Many manufacturers now offer their standard line with little more than a slot for operation, so the window can have a more consistent appearance regardless of the color selected. The finish of the window itself can be an issue when aluminum windows replace wood. The appearance of enameled aluminum may not be compatible with stained or even painted historic interior woodwork. With the obvious exception of stained glass, historic glass prior to the mid-20th century was almost always clear. Use of reflective or tinted glass as replacement inappropriately changes the historic character of a building. Some historic windows had obscure glass, particularly steel industrial sash. Although retaining the obscure glass might be desirable, it may usually be replaced with clear glass if its retention would limit the new uses for the building. Some post-World War II buildings were glazed with tinted glass originally. When the color of the glass was part of the architectural design, any replacement windows or new glazing must be consistent with the historic appearance. Replacement windows where no historic windows remain. Many projects involve replacing windows that are not historic or installing new windows where they are missing altogether. Replacements may either reproduce the historic windows based on physical or documentary evidence, or they may be a simple generic window that is consistent with the basic historic character of the building. In the case of this building, no historic windows remained. Replacing the windows to match the non-historic and incompatible windows in place at the beginning of the project would not meet the standards. While documentation of the historic windows was available, replicating these windows was not required. Instead, compatible replacement windows were installed that were the same type as the original windows, but differed somewhat in the size of the panes and the number of divisions. The existing aluminum replacement windows in this house were replaced with aluminum clad wood as part of a second rehabilitation. Although the frames of the new replacements installed were somewhat wider than they would have been historically, this was acceptable because no historic windows remained. However, the insertion of a pair of windows in the wide single opening on the first floor was not appropriate. Accordingly, the two windows that had been installed in the large opening were required to be replaced with a single wide unit in order for the project to meet the standards. Okay. Are there any questions about windows? Okay. All right. Again, if you do have any questions during the course of this, please put them in the Q&A portion, and I will get to them at the end of each of these segments. All right. Seeing none, we will continue on. All right. Next up is installing new systems in historic buildings. Keep the primary goal in mind. Please note here that the exposed brick was an existing condition in the building before the rehabilitation began. So the goal is to preserve the character of the historic building while making the building functional and safe for today's needs. The system components that are most likely to impact the character of historic buildings are HVAC ductwork, sprinkler systems, and air handling equipment. Because the character of historic buildings varies from rough and industrial to finely finished and highly ornamented, the appropriate approach to the installation of new systems will vary as well. Applicable standard number 2, the historic character of a property shall be retained and preserved. The removal of historic materials or alterations of features and spaces that characterize a property shall be avoided. So this is a historic view of the space shown in the previous slide after the rehabilitation. This is the Mid-Continent Life building in Oklahoma City with the mosaic tile floor in the main entryway. Where a drop ceiling can be avoided, it should be. A preferable solution is to install chases and soffits to conceal systems while maintaining the historic volume and ceiling height of the space. Make sure these elements do not impact historic features like woodwork, transoms, windows, or doors. It is also preferable to locate these soffits within secondary spaces, such as individual offices or apartment units beyond the primary corridor. This illustration depicts a solution that will preserve the volume and historic features and finishes of a corridor. Where where it is important for an existing or historic ceiling to remain exposed, such as tin or beadboard shown here, it is preferable to group ductwork, conduits, and pipes within one chase or soffit. Top left, all systems were grouped along a plain beam at the column line, and the soffit will be finished with gypsum board and painted to match the ceiling. This solution may not be appropriate where a beam is architecturally distinguished by crown molding or other features. The bottom right, the soffit is located along the interior partition wall. Additional examples of spaces where a ceiling should remain exposed. The treatment shown here located systems within new partition walls and above drop ceilings in secondary spaces to preserve the pressed metal ceiling. Ductwork was concealed above the ceilings of the new dressing rooms in a ladies' dress shop. In some cases, it is acceptable to use exposed ductwork in finished spaces, primarily only in commercial spaces where a soffit would obscure or damage a historic feature or finish, such as pressed metal or woodwork. Where ducts are exposed in finished spaces, they should be painted to reduce their impact on the historic interior space. As you can see in these images, because the unpainted duct on the right reflects the sunlight coming through the storefront, it is more attention grabbing than the painted duct on the left. Be aware that the shape and size of the ducts will make a difference on the extent to which these new intrusions affect the historic space. Rectangular or square ducts can often be attached closer to the ceiling and fit in a smaller space than spiral. However, the hangers used may create a more cluttered appearance and attract more attention. While these examples are not in a historic building, this solution may be appropriate in rehabilitation projects. The ducts shown here are an inflatable material that expands when the air is on, similar to a windsock. Rather than installing registers at designated locations, there are small perforations along the side of the duct that allows the conditioned air to escape. The impact on this space is minimal and the duct blends in well with the ceiling. This former bank building in Rocky Mount, North Carolina, had low ceilings throughout the building, with the exception of the first floor, and previous work included the installation of ductwork in the corridors, utilizing historic transoms to access individual offices. The recent rehabilitation included removing this inappropriate ductwork from the corridors and restoring the corridor glazing. In order to remove the inappropriate features from the corridor ceilings, building systems including ducts, electrical, and communications cables were routed along the base of the exterior walls, below the historic window sills, and concealed within a built-in casing that resembles a window seat or low counter. Plumbing can also negatively impact historic spaces. Any system components that will be visible should be described in Part 2 of the tax credit application with proposed finish or lack thereof if specified. This large building was adapted for office and administrative use. Prior to the rehabilitation, spaces were deteriorated but still conveyed an overall character of a finished building. Walls and ceilings were plaster, floors and stairs were terrazzo and marble. Though the building was deteriorated prior to rehabilitation, the historic character of the finished spaces remained and should have been preserved. For this type of space, exposed systems are discouraged. Even if the exposure of some elements is unavoidable, it should be limited to a single painted duct or two located in the least obtrusive space. The amount of exposed systems shown in this corridor is incompatible with almost any type of building. New systems should not distract from the historic space. The manner in which the conduit was installed in the upper right does not respect the architectural details of the space. The conduit should have been routed along the crown molding, crossing the woodwork in only a minimal number of locations. This example demonstrates the possibility of choosing systems with low profile and unobtrusive vents on the right, and how painting can drastically reduce intrusiveness. Note that the vents were located within the larger patterned field rather than replacing the border pattern. Lower left images shows the sprinkler system installed in a manner to preserve the historic decorative finishes. Note that in contrast to previous slide, this system follows the architectural lines of the room. A new sprinkler system was installed in this large lobby space. Note that the primary line was located close to an existing beam and on the opposite side of the column line from the main entry. And individual sprinkler heads were evenly spaced in the center of each span, with branch lines wrapping the bottom of the beam for connection to the trunk. The pipes were painted to blend in. Exposed systems are almost always incompatible treatments in historic houses. Systems should be located in attics, basements, or crawl spaces, or within wall cavities. In limited areas, it may be acceptable to lower a ceiling or enclose ducts, pipes, and conduit within soffits and chases. So, for the appropriate installation of new systems in historic industrial spaces. Exposed, unpainted ductwork and equipment is consistent with the character of industrial spaces that historically house equipment and machinery. As shown in this example, ducts can also be inserted between exposed joists for a truly minimal impact on an industrial space. Though there is more freedom concerning the installation of equipment in these industrial spaces, there are certain things that must be avoided. Ductwork must not be installed in front of windows, as shown here. If ceilings and joists are too low to keep systems above windows, then ductwork must be set back a sufficient distance from the windows so that it is not visible from the exterior and the windows are not covered or shortened on the interior. In this example, most of the ducts and sprinkler systems are exposed, but part of the equipment and air returns are located in a soffit and within new partition walls. Because the majority of the open ceiling has remained exposed, this is an acceptable solution. However, concealing systems in industrial buildings is generally not the best solution. In this case, the open ceiling joists should have remained exposed to a much greater extent. Leaving a remnant of the space preserved along the exterior walls is not enough. The overall character of the space has been changed. The inappropriate installation of new lighting systems can also have a significant impact on the character of spaces, such as installing open ceiling grids to support a lighting system. As you can see in the image at the upper right, while the open joists and structure are still visible above the grid, this new feature introduces a whole new layer of structure, which in this case effectively shortens the windows. This treatment is not recommended. The image at the lower left shows a better lighting solution with individually suspended light fixtures. It has been common in more recent times for buildings to be constructed as shell spaces ready for specific tenant fit-outs. These buildings were always meant to be finished spaces, but as they become candidates for rehabilitation, they are often empty shells once again. The interiors of these buildings are not industrial, though many have a similar appearance in their pre-rehabilitation state, nor are they finished spaces. Therefore, an acceptable solution falls somewhere in between. Although, where strong evidence exists, such as clear evidence of a drop ceiling in the window shown here, it is best to use treatments that were utilized historically. In this project, drop ceilings will be reinstalled at the same height and most systems will be concealed in the space above. This office building is another example of a historic shell building. The interiors had always been finished spaces, but the finishes that existed prior to rehabilitation were not historic finishes. The initial proposal included exposed systems throughout the corridors. This treatment imparts the character of an unfinished or industrial space, and thus is not appropriate in the historic office building. To bring the project into conformance with the standards, the pipes and ducts were painted and then floating panels were installed to create a ceiling. This solution appropriately maintains the finished character of this shell building, but it would not be appropriate in an historic building that retained extensive finishes prior to rehabilitation. Installing new mechanical equipment, especially when locating it on the rooftop, must meet the standards that relate to new construction, exterior alterations, and new additions. Standard 9, new additions, exterior alterations, or related new construction shall not destroy historic materials that characterize the property. The new work shall be differentiated from and shall be compatible with the massing, size, scale, and architectural features to protect the historic integrity of the property and its environment. Standard 10, the new additions and adjacent or related new construction shall be undertaken in a manner that if removed in the future, the essential form and integrity of the historic property and its environment would be unimpaired. These buildings, located in Washington, D.C., are good examples of what not to do. For additional guidance is available on the National Park Service's website using the Search by Topic feature found on the homepage. All right. Any questions, comments, or concerns about installing new systems in historic buildings? All right, seeing none, we'll just keep moving right along. All right, here's a biggie. Meeting modern requirements in historic buildings, mainly looking at code requirements. We've got hazardous materials abatement, ADA, fire and life safety, seismic upgrades, and energy efficiency. So the most common hazardous materials found in historic buildings is lead-based paint. It was commonly it was commonly used up until approximately 1980, and or the U.S. Department of Housing and Urban Development takes the lead on lead hazard controls. Treatments now recommended are more sympathetic to historic buildings. So, abatement versus interim controls. The definition of abatement is a treatment lasting at least 20 years, which often necessitates the removal of painted trim and other millwork, the encapsulation of surfaces with thick paint, and the enclosure of affected features behind mechanically fastened wallboard. The definition of interim controls is a treatment lasting at least 6 years, which are generally tied to proper maintenance and good hygiene. The most common interim control is paint stabilization in areas of friction and high impact. Interim controls cost less and are more sympathetic to historic buildings. Accessibility. Here's the big one. So when we're talking about ADA compliance and accessibility, modify grade if possible. These steps can be easily adapted because they are relatively low to the ground. Ideally, existing entrances should be made accessible without major modifications. In an instance where this is not achievable, an accessible entrance at grade is compatible in a compatible new addition. If historic buildings cannot be accessed at grade, then ramps should be sensitively placed rarely on front elevations. Here are the requirements for ramps as per the ADA and egress in the International Building Code. It's limited to a vertical rise of 30 inches between intermediate landings, may not exceed 1 in 12 or an 8% grade. Cross slope may not exceed 1 in 48 or a 2% grade, and the width is typically 44 inches or 36 inches between handrails if provided. In this example, the front entrance could not be easily adapted, so a ramp sensitively placed on the side was utilized. Exterior lifts are also an option provided they are appropriately placed. Stair towers can be added to the rear of a house. But the addition must meet the standards, as well as requirements for ADA and egress. This is an example of an incompatible stair tower. The new stair and elevator tower was added to the front of the elevation, which is not recommended, as it increases the size and massing of the building's facade. Also, the original building facade is symmetrical, and the addition onto one side makes this no longer the case. Adding elevators on the interior. New elevators inserted on the interior for accessibility. Design is contemporary, yet retains the industrial character of the space. And here are examples of where not to place an elevator, which is in the front parlor of a highly decorative interior. The location of the new elevator in the front parlor does not meet the standards. And elevators don't have to be large. This is a small elevator tucked in a residual space used to access a private meeting room. Accessible features on the interior. Ramps have been sensitively placed on the interior of this historic hotel. There's also the insertion of a lift. The location of the lift was placed into the former side niche. So, respect historic hardware. So a way to do this is to keep it in place, but to make it non-functional. Fire and life safety. The construction industry is moving away from individual codes in different parts of the country towards one common code, the International Building Code, or the IBC. The IBC and IEBC, or the International Existing Building Code, are more performance based in regard to historic buildings, as opposed to the prescriptive nature of codes for new construction. So, whenever there are any code issues about, concerning historic properties, in dealing with code officials, I always recommend that a conversation be had with those code officials about the utilization of the international existing building code. Fire codes are also becoming more sympathetic to historic buildings. Individual states have also adopted rehabilitation subcodes. New Jersey took the lead in this endeavor, and this subcode acts as a national model. Talk early and often with your local code official and seek variances whenever possible. I cannot stress enough in the um, benefits of having a good working relationship with your local code official. Here's a list of common code, fire, and life safety issues. Adding a second means of egress, which may include constructing an external elevator or stair tower, adding a new elevator on the interior, adding a new set of stairs, shortening or truncating corridors, and modifying windows for egress. So, adding a stair or elevator towers on the exterior. Many exterior additions are constructed to meet egress and accessibility when these requirements cannot be fulfilled on the interior. This metal stair was sensitively placed at the rear of this building and meets the standards. Its slightly embellished design is appropriate for this high style building. Simple buildings get appropriately simple masonry stair towers at the rear. This is a long warehouse with a new elevator and stair tower. Adding stairs on the exterior may be recommended when adding them on the interior would adversely affect or impact historic fabric. As in the case of this building and its decorative tile work and wood trim in typical corridors necessitated a higher level of preservation. As per the existing fire escape, exterior stairs will be added to the secondary elevation for egress. Here you can see the location of the new stair so as to retain the distinctive corridor. Modifying windows for egress. There is a minimum egress requirements of 20 inches clear in width, 41 inches clear in height, lower height if window is wider, the open area being 5.7 square feet minimum with a sill height of 44 inches minimum. Often required in small and medium-sized buildings, Code requires taller buildings to have other provisions for egress. It's a continuation of that list of issues and concerns. Enclosing stairs for fire separation, widening of stairs, increasing the heights of railings, and infilling windows for fire separation. If a variance from a code official cannot be obtained and significant stairs require enclosure, glazed partitions are preferable to solid partitions. The volume of the space is still understood despite the insertion of a glass partition. In the event of a fire, the doors will automatically close. So this is an insertion of the glass partition wall in a school stair hall, and it provides the necessary fire separation. So what about stairs that do not meet code? This is an example of over 75 houses in a historic district that were rehabilitated for affordable housing. The old stairs were very narrow and shallow and had a low head height and did not meet code and could not meet code based on where they were located. So new stairs were constructed but kept simple. Modifying handrails to meet code. A guardrail for egress is typically 42 inches tall, except in residences where they may range from 34 to 38 inches. A sphere of 4 inches in diameter, or the approximate size of a baby's head, cannot pass through the railing. We do have a bulletin um, or interpreting the standards bulletin number 46, which is all about modifying historic handrails to meet building code. The use of structural glass when modifying rails works very well, as it still provides the historic visual presence of the feature while adding the structure and the height needed for a code compliant railing. Again, this is what it looks like for glazing in front of a mezzanine railing looking into a historic banking hall. It provides the height needed, but also provides the space needed, as those slats are probably more than 4 inches apart. Encourage owners to construct sample installations. This mock-up demonstrates that the design adversely impacts the appearance of the delicate railing and did not meet the Secretary standards. So a revised design was done to meet the standards. The structure of supplemental railing was made thinner and the details were added to better relate to the historic railing. In some cases, a curb can be added to the base of a historic rail to meet height required. In terms of fire separation, avoid bricking in windows for said fire separation. When an exterior wall of a building is 5 feet or closer to an adjacent building, Fire exposure may come from either the inside or the outside of the two buildings. Therefore, fire separation in some form must be provided. In the event of a fire, sprinklers keep the windows cool so they do not explode. And if they do explode, then water keeps flames from getting through. For this treatment, sprinkler heads were required at the rear elevation. So there actually are sprinkler heads at the window heights on the interior of the rooms. This is a historic Forest Service cottage in an area of high fire activity sprinkled from the exterior. Here you can see that this exterior sprinkler system in action as it relates to an incoming fire. The creative insertion of new systems, fire separation, telecommunications, can be done with beams being slightly lowered to include these new systems, as we discussed earlier. Continuing on, some more issues and concerns are modifying corridors for fire separation, glass transoms, glazed panels and doors, distinctive doors, and retention of pressed tin ceilings. In the case of retention of pressed tin ceilings, preservation of pressed metal ceilings often requires the insertion of fire separation between the floors with Type X wallboard in mixed-use buildings. So basically, you would have to remove the ceiling, put up the wallboard, and then put the ceiling back over top of the wallboard. In the case of retention of historic corridor doors, in this example, the distinctive corridor doors were kept in place with a new door within a door inside of a classroom to provide for not only fire separation, but also security and privacy. Seismic upgrades. This is in these photos is damage to historic buildings from the Seattle earthquake that occurred February 28th, 2001. Seismic upgrades must be placed in the least intrusive location as possible. X or K bracing, as well as shear walls, must not interrupt windows, storefronts, or significant interior spaces if at all possible. Upgrades are preferable on the interior. If portions of a building are dismantled for stabilization, the interior must be returned to its original appearance. No brick or concrete left exposed. Avoid the extensive use of steel bolstering in unreinforced concrete. New technologies will be considered if they do not impact the property too greatly. For example, wrapping columns in fiberglass and epoxy to avoid shattering and installing diaphragms to reinforce roof structures. So here is an example of a successful seismic upgrade. This is what the ferry building to rehabilitation. And the best seismic upgrades are those that are least visible. Basically just beefing up some of the structure. Here's an example of another successful seismic upgrade in San Francisco. This is the Pier 1. This is what it looked like prior to rehabilitation. And there were seismic upgrades in the office areas so that they were not readily visible to the public in the common areas. So this is a historic bank building with the rehabilitation that required a seismic upgrade. And this is an example of an unsuccessful seismic upgrade. So the insertion of mezzanines for seismic reinforcement impacted the historic banking hall too greatly and did not meet the standards. New mezzanines not only divided the space horizontally, but intersected multi-story arched windows midway. This is a building that was severely damaged in a 2002 earthquake. And in 2005, this is what it looked like in 2005 after rehabilitation with rebuilt parapets and storefronts and was a successful seismic upgrade. X-bracing was required in some locations on the ground floor, but the overall quality of the project made up for this change. The interior was in poor condition prior to the rehabilitation. The atrium was reopened and the skylights restored. In terms of energy efficiency, look to preservation brief number 3 on conserving energy in historic buildings. Good old-fashioned storm windows go a long way towards conserving energy. Especially if the windows are unique. And yes, you can put storm windows on steel sash as well. In this example, interior storms align with the window divisions of the historic steel windows. So get back to the basics and treat areas of infiltration first. Caulk and weather strip historic doors, windows, and other penetrations to eliminate air infiltration. Focus attention in those areas that are proven to get most efficiency. As for insulation, attics are the most important. Avoid insulating primary spaces as this adds bulk to the walls and therefore can affect how features such as windows and windowsills appear on the interior. Basements and crawl spaces are also good places to insulate. Avoid insulating character-defining spaces, as I said, and most air escapes vertically, so attics are the most important place to insulate. Is blown-in insulation appropriate? Not necessarily, because it requires removal of historic fabric on the interior and exterior, and it may trap moisture and cause paint failure if improperly installed. All right. Are there any questions, comments, or concerns about that? Okay. Seeing none, we will move on to evaluating substitute materials for use in historic buildings. All right. In terms of substitute materials, Standard 6 applies. Standard 6 states deteriorated historic features shall be repaired rather than replaced. Where the severity of the deterioration requires replacement of a distinctive feature, the new feature shall match the old in design, color, texture, and other visual qualities, and where possible, materials. The standards do allow for the replacement of historic material as part of a rehabilitation project if it is demonstrated that it is damaged and beyond repair. The replacement should preferably match the original material, or in some cases, it may be a substitute material. The tradition of using cheaper and more common materials in imitation of more expensive and less available materials is a long one. George Washington used wood painted with sand impregnated paint at Mount Vernon to imitate cut ashlar stone. In the late 19th century and early 20th century, new technologies developed more economical, practical, and durable products such as hollow concrete block, pressed metal, linoleum, and embossed wall coverings that could be used in place of more expensive building materials. Many of the materials used historically to imitate other materials are still available. These are referred to as traditional materials: wood, cast stone, concrete, terracotta, and cast metals. Building product manufacturers continue to introduce new materials meant to replicate traditional materials. In the last few decades, new families of synthetic materials, such as fiberglass, acrylic polymers, and epoxy resins. Determination of the appropriateness of proposed materials and treatments is made in accordance with the standards as well as National Park Service guidance. Technical Preservation Services publications specifically related to the use of substitute materials include Preservation Briefs 16, The Use of Substitute Materials on Historic Building Exteriors, Preservation Brief 8, Aluminum and Vinyl Siding on Historic Buildings, and Preservation Brief 42, The Maintenance, Repair, and Replacement of Historic Cast Stone. These criteria should be used to evaluate a proposed application of substitute materials: the need for substitute material, the amount and location of proposed application of the substitute materials, visual and other match for the historic materials to be replaced, and physical compatibility of substitute materials. If the historic material or element is not missing entirely from the structure, the first step is to determine whether deterioration of the surviving historic material is sufficient to require replacement in kind or with a new material. When to consider using substitute material in preservation projects, If the original materials have performed poorly, if there is no source for the original material, if craft persons are not available to replicate the historic element in its original material, or current code requirements do not permit the use of the historic materials. The building facade of this row house reveals that the majority of the historic serpentine veneer stones show extensive delamination. The stone is no longer quarried because the material performed poorly. In this case, precast concrete replacement that matches the color, dimensions, and surface of the originals has been used successfully. The replacement material needed to closely match the historic stone in size, shape, dimension, texture, and color in order to preserve the historic character of the facade. An alternative stone, such as limestone, could have been cut to match some of the visual characteristics of serpentine, but it could not duplicate its distinctive green coloring. Therefore, the material that offered the most potential for use as a replacement was precast concrete. More information about this example and treatment can be found in Preservation Tech Note Masonry Number 1. Please be aware that this approach may not be appropriate in all situations involving deteriorated serpentine or other types of historic masonry. Total replacement of the deteriorated stone veneer of a historic building using a substitute material should be considered only after careful analysis and with the consultation of the State Historic Preservation Office and National Park Service so that the integrity of the property is not compromised. The unavailability of historic craft techniques and lack of skilled artisans complicate any rehabilitation project. This is particularly true for intricate ornamental work such as carved wood, wrought iron, or carved stone, such as seen in the intricate carving of the lion in this example. Efforts should always be made, prior to replacement, to seek out artisans who may be able to repair ornamental elements and thereby save the historic features in place. Life and safety codes often require changes to historic buildings. For example, many cities in earthquake zones have laws requiring that overhanging masonry parapets and cornices or freestanding urns or finials be securely re-anchored to new structural frames or be removed completely. In some cases, it may be acceptable to replace these heavy historic elements with light replicas. In other cases, the extent of historic fabric removed may be so great as to diminish the integrity of the resource. This could affect the significance of the structure and jeopardize National Register status. Department of the Interior regulations governing the Historic Preservation Tax Incentives Program make clear that Secretary of the Interior's standards for rehabilitation take precedence over other regulations and codes in determining whether a project is consistent with the historic character of the building undergoing rehabilitation. Different materials and elements will play an important role in contributing to the historic character of a building's historic appearance. where a particular feature contributes significantly to the historic character of a building. The material or materials that make up that feature are likely to require a closer replacement match the material making up a feature that may be of lesser importance. A careful evaluation of the building and an understanding of the historic significance of its various materials and elements will assist in determining the degree to which a substitute material may be acceptable. The overall visibility of a character defining material or feature is is as important to determine an important determinant in whether a substitute material will be appropriate. Generally, the more visible a feature is, and the more important it is to the building's historic character, the more likely it will affect that character. A replacement cornice using a substitute material proposed for a two-story building would have to match more closely the historic element than one intended for a 10-story building. After careful inspection, the slate roof of this circa 1895 former brewery was determined to be beyond repair. During rehabilitation, the slate roof was replaced with a high quality asphalt based fiberglass shingles. The new asphalt shingles are the same size and color as the original slate and have similar shadow lines. The roof, with its many towers, turrets, and monitors, is clearly a distinctive and prominent feature, but because of the massive scale and height of the building, it can only be viewed at a considerable distance. For this reason, a substitute roofing material was acceptable in this instance. Materials on the rear elevation or side elevations with limited visibility due to the proximity of neighboring buildings may be of secondary importance to the building's character. Here is an appropriate use of fiber cement siding on the side and rear elevations only. All replacement work reduces to some degree the historic character of a building. While the limited use of substitute materials on a historic building is acceptable, there may be a point where the amount of replacement material becomes excessive when the overall sense of the building as a historic structure is lost and the building's integrity is diminished to an unacceptable degree. When the Part 3 request for certification of completed work was submitted for this project, it was clear that the work was not completed as proposed in the earlier submissions. The entire exterior had been reclad with fiber reinforced cement siding that does not match the historic clapboard. As installed, the new siding does not match the exposure or depth at the lap joint of the historic clapboard. The cement board features an exaggerated wood grain texture that does not match the historic material removed. The substitute material must closely match in the design, color, surface texture, surface reflectivity, finish, and details of the material or element to be replaced. The defining characteristics of a historic roofing material usually includes the size and shape of the shingle, as well as its thickness, color, and reflectivity. An asphalt shingle may be available that matches the size of a particular roofing slate, but its thin profile and granular surface may bear little resemblance to slate. Similarly, a polymer-based slate substitute may match the thickness and surface texture, but only available in a larger size than the historic slate. Before the appropriateness of either substitute material can be evaluated, the characteristics of the historic roof that are most important to how it is perceived on a particular building must be identified. This may lead to choosing one substitute material over another or rejecting all if the resulting difference appears to be too great. The use of substitute materials should take into consideration ongoing maintenance and the difference between the new material and adjacent or related existing materials. The wood elements shown in this photo all have similar maintenance requirements. Replacing the clapboard with fiber reinforced cement siding, for example, would create new maintenance requirements for the different materials. Repair or replacement work using physically incompatible substitute materials may damage surviving historic fabric and therefore is inappropriate. Here, elastometric caulking was used instead of mortar and damaged the brick around. Proposed substitute materials may have rates of thermal expansion and contraction and rates of vapor permeability that differ from the existing historic material and therefore may perform differently. Factors that can impair the performance of substitute materials over time include ultraviolet light, moisture penetration, and stresses caused by said changing temperatures. Many substitute materials are marketed as maintenance-free, which often means a short lifespan. As a result, the feature must be replaced in its entirety instead of incrementally. Keep in mind that no material is really maintenance-free. While the goal may be to achieve an exact match when replacing historic material, most replacement involves some measure of change, if only minor. For example, new marble today will not be exactly the same as historic marble, even if it's from the same quarry. Thus, the evaluation of any replacement needs to take into account the quality of the match needed in terms of both appearance and performance for a given situation. Always ask for a sample of the proposed substitute material and look at a sample installation. Preservation Brief number 16 provides pros and cons of various substitute materials for use on the exterior of historic buildings. For additional resources, visit the Technical Preservation Services publications online, which include preservation briefs, preservation tech notes, and ITS bulletins, or interpreting these standards. Consumer publications often provide information that can be used to compare various materials, costs, benefits, and lifespans. Thank you, and I will now take any questions, comments, or concerns about anything that we covered today. We are about out of time, but those were the 4 topics that I get asked about more often than not, and felt that it was a worth visiting today. So, right. Again, if you need a certificate of completion, please put your name that you want the certificate to be given to in the chat. I have also provided in the chat my contact info again, and then in the handouts, I've given the handouts that I've been giving for the past 2 days, but I've also included um, the publication of the Secretary of the Interior's standards and guidelines for rehabilitation for your ease and convenience. John, you should be getting a once the recording is so once we stop recording and it gets converted, you will be getting a notification and should be getting a notification in your email about how to access that recording. So. Okay, well, if I don't, since I don't see any other questions, comments, or concerns, please feel free to email me or give me a call if you have any after the course of this, and I will leave you for today. So thank you all so much for being here and going through this training. I hope it was helpful, and I hope to talk to you about your various projects over time. Thank you. Have a good one.